This is section 7.1 for Math 2 Honors. Find the length of the hypotenuse of a right triangle with a leg length of 5 and 8 and leave the answer in simplest radical form. I'm going to start with a picture of a right triangle. Remember, the hypotenuse is the longest side, which is opposite the 90-degree angle. The other two sides are your legs. So we have leg length of 5 and 8, and we want to find the hypotenuse. I'll call that h. Pythagorean Theorem tells us that if you get the sum of the squares of the legs, it's equal to the hypotenuse squared. So 5 squared is 25. 8 squared is 64, equal to h squared, and 25 plus 64 is 89. Take the square root of both sides, and h is equal to the square root of 89. And 89 is a prime number, so that is as simplified as we can get it, so that's our answer. Part B, find the length of the leg of a right triangle if one leg is 3 square root 5 and the hypotenuse is 10. So again, start with another picture. Hypotenuse, which is opposite the 90-degree angle, is 10. And one of the legs is 3 root 5. It doesn't matter which one you make 3 root 5. And we're trying to find the length of the missing leg. So again, set up Pythagorean Theorem, so 3 root 5 squared plus x squared is equal to 10 squared. 3 root 5 squared is going to be 3 squared times the square root of 5 squared plus x squared equals 100. 3 squared is 9. Square root of 5 squared is 5. Plus x squared equals 100. 9 times 5 is 45. Subtract 45 and you get x squared is equal to 100 minus 45, which is 55. Take the square root, and x is the square root of 55. 55 is 5 times 11, and can't be simplified any further than it is, so we're going to leave it. X equals root 55. Part C, a 20-foot ladder is leaning against a wall. The base of the ladder is 4 feet from the wall. How high up the wall is the ladder? So here's our wall. Here's our ladder leaning up against the wall. And notice we get this right triangle shape. The ladder length is 20 feet. That's our hypotenuse. The base of the ladder is 4 feet from the wall. So that is the distance along the ground. And we're looking for the height. I'll use lowercase h for the height, or how high up the wall is the ladder. Using Pythagorean Theorem, we get 4 squared plus h squared equals 20 squared. That's 16 plus h squared equals 400. H squared is going to equal 400 minus 16, which is 384. Take the square root, we get h is the square root of 384. Here it asks us to round our answers to the nearest tenth. So use a calculator and type in the square root of 384. Get 19.5959, so on. But we're rounding to the nearest tenth. So 19.6. And we're talking feet. Part D. A 48-inch TV screen is on sale at Best Buy. The width of the TV is 26 inches. Find the height of the TV. Remember, the TV is advertised by the length of its diagonals. So here's our TV screen. It's a 48-inch TV, so if we draw a diagonal, the diagonal length is 48 inches. The width of the TV is 26 inches. It's a right triangle, and we're looking for the height. Use Pythagorean Theorem again. H squared plus 26 squared is equal to 48 squared. 26 squared is 676. 48 squared is 2,304. So h squared is equal to 2,304 minus 676, which is 1,628. H is equal to the square root of that, which is roughly, we're going to round this to the nearest tenth, 40.3. And we're talking inches. Part E, we're solving for x. Using Pythagorean Theorem, x squared plus 7 squared is equal to 5 square root of 3 squared. So that's x squared plus 49 is equal to 5 squared times square root of 3 squared. 5 squared is 25. Square root of 3 squared is 3. So we get x squared plus 49 equals 75. 75 minus 49 is 26. So x is equal to the square root of 26. Here in this problem we're not asked what form to leave it in, so I'm just going to stop there and leave it as x equals the square root of 26. This is section 7.2. And part A, we're asked to find the value of x and to leave that value in simplest radical form. We're given a right triangle. This is a 45, 45, 90 right triangle. And the way we're going to handle this is we're going to draw another 45, 45, 90 right triangle that's similar. We know they're similar by angle-angle similarity. And it has a hypotenuse of 1. And this is, has a hypotenuse of 2. And the side lengths are square root of 2 and square root of 2. So this is just, the smaller one is just, it's a 45, 45, 90 right triangle that we memorize. And we're able to, it's going to be similar to all 45, 45, 90 right triangles. And so we can use it to solve for x in this case by setting up a proportion. So x is the hypotenuse of the larger one over the right side of the larger one. So x over 12 is equal to the hypotenuse of the smaller one, 2 over square root 2. I cross multiply and I get the square root of 2 times x is equal to 2 times 12. So, and then divide up by square root of 2, and you get x is equal to 24 divided by the square root of 2. And we can't end with a square root of 2 in the denominator. So I'm going to now multiply the numerator and the denominator by square root of 2 to rationalize the denominator. And I get 24 times the square root of 2 over 2. And then I'm going to reduce that. 24 divided by 2 is 12. And so we end up with 12 times the square root of 2 is the length of x. For B, I've got another 45, 45, 90 triangle, so I'm going to draw another 45, 45, 90 triangle that I do know the side lengths of. And I know they're similar. The triangles are similar by angle-angle similarity. And set up a proportion here. This time I'm going to set up it a little differently. I'm going to write x over square root 2 is equal to 8 over 2. This proportion also works, and I like this one because I can divide the 8 and the 2. And I get x over square root 2 equals 4 over 1. And then when I cross multiply, I end up with 1 times x equals 4 times the square root of 2. Part C, we have a 30, 60, 90 right triangle. And I'm going to draw another 30, 60, 90 right triangle, one that we know the side lengths of. So here's 90, here's 60, here's 30, and across from the 90 is, we're going to side length 2, across from the 30, side length 1, across from the 60 is the square root of 3. And here we want to solve for x and for y. So I'm going to start with x, matching up corresponding parts. X over 1 is equal to 8 over 2. You can reduce that. X over 1 is equal to 4 over 1. When you cross multiply, you end up with x is equal to 4. And for y, I'm going to again match up corresponding parts. Y over square root 3 is equal to 8 over 2. You can reduce 8 over 2. You get y over square root 3 is equal to 4 over 1. When I cross multiply, I end up with y is equal to 4 times the square root of 3. Part D, again we have a 30, 60, 90 right triangle. I'm going to draw another 30, 60, 90 right triangle that's similar to this one, but one I know the side lengths of. Again, the smallest side is 1, the largest side is 2, the side in between across from the 60 is root 3. And to solve for x, I'm going to write the proportion x over 1 is equal to 10 root 3 over 3. 10 root 3 over root 3. So the root 3's cancel out, and you end up with x is equal to 10. To solve for y, I'll set up a proportion again, this time y over 2 is equal to 10 root 3 over 3, over root 3. And then the root 3's cancel out, and you get y over 2 is equal to 10 over 1. Cross multiply, and you get y is equal to 20. For E, we have a 45, 45, 90. I'm going to draw another 45, 45, 90 that we know the side lengths of. And set up a proportion because these triangles are similar. X over square root 2 is equal to 24 over 2. Reduce. Cross multiply, and you get x is equal to 12 times the square root of 2. Part F, on the left-hand side, I'm going to draw another 45, 45, 90. Where this side's 2, this side's square root of 2, this side's square root of 2. And set up a proportion. X over 2 is equal to 8 square root 5 over square root 2. We're going to cross multiply here and get x times the square root of 2 is equal to 2 times 8 square root 5. 2 times 8 square root 5 is 16 square root 5. Divide by square root of 2, and you get x is equal to 16 square root 5 over the square root of 2. Can't have a square root in the denominator, so we need to multiply top and bottom by square root 2. And so we end up with 16 times the square root of 10 over the square root of 4, or 2. 16 over 2 reduces to 8 root 10. Part G. Actually, I'm not done with F. F, we got another side to look at. Set up another similar triangle here, 30, 60, 90, with the side lengths that we know. And set up a proportion here. X over square root 3 is equal to 18 over 2. Reduce. Cross multiply, and you get x is equal to 9 times the square root of 3. Part G. Again, set up another 30, 60, 90. One from which we know the side lengths. And set up a proportion. Here, x over 2 is equal to 7 root 3 over root 3. Reduce. Cross multiply, and you get x is 14. Next one, we have a 30, 60, 90 as well. Draw one that we know the side lengths of. One always goes across the 30, root 3 is always across 60, 2 is always across 90, and set up a proportion. So here, I'll say x over root 3 is equal to 5 root 7 over 1. And so when we cross multiply, we end up with x is equal to 5 root 7 times the square root of 3, which is 5 square root of 21. Section 7.3. A says use the diagram to find the ratio for sine C. So C is right in the bottom right hand corner, and if that's our reference angle, no matter what, we can just put the side lengths of something that's similar to this triangle, which hypotenuse would be 1. The side opposite would be the sine of C, and the side adjacent would be the cosine of C. And actually, let me do this. This will work better. Because we don't know the side lengths of this one. Let's draw one that we do know the side lengths of. Okay, where this is the same angle, we'll call it angle C. This side would be the sine of C. This hypotenuse is 1. This is the cosine of C. And here we have the side length AB. Here we have the side length AC. Here we have the side length BC. And so setting in proportion, I'm going to write sine C over 1, coming from the small triangle, is equal to, well, AB corresponds to sine C, so AB over AC. And since sine C over 1 is the same thing as sine C, we found the ratio for sine C. So in a sense, this is saying, hey, solve for sine C. What do you get? And so we end up with the sine of C is the length AB over the length AC. In next diagram, we have, we draw a triangle that's similar to this. We're focused on angle A. Here the hypotenuse, the right triangle, so this is 1, this side would be the sine of A, the side opposite, this side would be the cosine of A. And we want tangent. Tangent is sine over cosine. In the other triangle we have side length AB, side length BC, and side length AC. So we know tangent is sine over cosine, so I'm going to write sine A over cosine A from the smaller triangle, and find corresponding sides over on the left side. That's BC over AB, and then finish this off. Well, sine A over cosine A, that's tangent A, is equal to BC over AB. And we now have our ratio for tangent A. Which of the following equals sine A? So again, I'm going to redraw this triangle. Just a smaller version. Here's with angle A. So this would be sine A here. This would be cosine A here. This would be 1. I'm going to draw one more now. This time with angle C. In reference to angle C, this would be the sine of C, the cosine of C, and angle 1. Because the reason I brought in the C is I'm looking at some of our answer choices, and we have C and we have A. So, which of the following equals sine A? Well, if we take a look at these two triangles, the two smaller triangles. They're from the same triangle. They actually have the same side lengths. And we see that sine A is the same thing as cosine C. And so cosine C is what we want. Sine A is not the same as sine C. Cosine A is, sine A is not the same thing as cosine A. And sine A is not the same thing as its tangent. Next one. Which of the following equals cosine C? So again, we can look at our two pictures that we drew, and we see cosine C and sine A are the same thing. And you can eliminate the others as well. Which expression can be used to find x? So I'm going to set up a triangle that's similar. One that has 90 degrees and 50 degrees, so they're similar by angle, but with a hypotenuse of 1. The hypotenuse is 1, then the opposite is going to be sine of 50 degrees. This side is going to be the cosine of 50 degrees. Now, if I look at all my answer choices, they all include sine. So when I create my ratios, I'm going to use the ratio sine of 50 and 1, and I'm going to use x and 3 as well. So I'll say sine of 50 degrees over 1 is equal to x over 3. And then we want to solve for x because all our answer choices are solved for x. So if I cross multiply, I end up with x times 1 is equal to 3 times the sine of 50 degrees. And then if I look at my answer choices, I see part D I want to go with. Part C, please don't do that. You cannot multiply the 3 times the 50 to get 150. C would be wrong. Part G, we want to find x. Again, I'm going to set up a similar triangle here. One that has a 90-degree angle and a 50-degree angle, but with a hypotenuse of 1. So this would be the sine of 50 degrees, and this would be the cosine of 50 degrees. And I want to solve for x. So x over 200 is going to equal sine of 50 over 1. If I cross multiply, I get x is equal to 200 times the sine of 50. Without a calculator, that's as much as we can do. I'm now going to use the calculator though. I'm going to type in 200 times the sine of 50 degrees, and I'm going to round it to the nearest tenth, and I get 153.2. And we're talking feet here. So that's how high the kite is vertically from the ground. On part H, we're going to draw another triangle that's similar. It's got a 40-degree angle, 90-degree angle, hypotenuse of 1. There's the sine of 40. Here's the cosine of 40. And I want to solve for x. So the fraction I'm going to get from the left triangle is x over 30. That will match up with sine 40 over 1. When I cross multiply, I end up with x times 1 is equal to 30 times the sine of 40. Need your calculator to go further. Type in 30 times the sine of 40 degrees. We get 19.3. I'm rounding to the nearest tenth. And that's our answer. Part I. I'm going to draw another triangle below it that's similar. Got a 90-degree angle here and a 51-degree angle here. Hypotenuse is 1. This is the sine of x and the cosine of x. From the larger triangle, I'm going to set up a fraction, x over 8, and then set up a proportion with corresponding parts. Cosine of, oops, I put x, it should be 51. Maybe fix that picture there. So cosine of 51 degrees over sine of 51 degrees. And when you're using sine and cosine, well, let's just keep in mind sine over cosine is tangent. So I'm going to do this. I'm going to flip every fraction over. I'm going to make it 8 over x instead of x over 8. And if you look at the corresponding parts, you're going to get sine 51 over cosine 51. The reason I'm doing that is because I know that sine over cosine is tangent. So now we have 8 over x is equal to tangent of 51 over 1. When you cross multiply now, we get x times the tangent of 51 degrees is equal to 8 times 1. And I want x by itself, so I'm going to divide by tangent. So x is 8 over tangent of 51 degrees. Type that into your calculator. And round it to the nearest tenth, and you get 6.5. Now on this one, we didn't have to change it to tangent. We could have just worked with sine and cosine. I just wanted to change it to tangent. It's totally by preference here. You do not have to do it that way. Next one, I'm going to set up a triangle that's similar to it. We have angle x here, 90 degrees. This hypotenuse is 1. This is the sine of x. Here's the cosine of x. So I want to set up a proportion of side lengths. So 13 over 21 would equal cosine x over 1. If I cross multiply, well, I don't need to cross multiply. I'm just going to flip the fraction around. I end up with cosine of x is equal to 13 over 21. So here's the case where please do not divide by cosine. We can't do that. This is a function that we're taking. The cosine of x is 13 over 21. We need to find out the angle measurement here, not a side length. And so we're going to have to use the inverse cosine function, which is the opposite of cosine, in order to get x by itself. So x is the inverse cosine of 13 over 21. To type this into your calculator, you usually have a second key or a shift key on your calculator that you're going to want to hit first to get the inverse cosine, and then type 13 over 21. And you should get roughly 51.8 degrees. Part K, I'm gonna draw a similar right triangle, hypotenuse of 1, an angle x. Here we have sine of x, opposite is sine, and adjacent get the cosine of x. And so setting up a fraction, we have 12 over 16 is equal to sine x over 1. I'm going to flip the fraction around, put sine x over 1 on the left-hand side is equal to, and I'm going to reduce 12 over 16 to, could divide them both by 4 and get 3 over 4. Again, I need to get x by itself, so I use the inverse sine function. And then use the calculator. Second sine, get the inverse sine, 3 over 4. We get 48.6 roughly. On part L, start with a similar triangle here, right triangle, angle 40, this is sine 40, cosine 40. So x over 35 is cosine 40 over 1. If you cross multiply, you get x is equal to 35 times the cosine of 40 degrees. And we didn't even need to go that far. Actually, if you look at our proportion, that matches up on part A. Solve for x, again start with on part M, start with a similar triangle. With a hypotenuse of 1. And we want to solve for x, so x over 88 is sine 35 over cosine 35. Sine over cosine is tangent, so this is x over 88 is tangent 35 over 1. When you cross multiply, you end up with x is equal to 88 times the tangent of 35 degrees. Use your calculator. And you get roughly 61.6 feet. Section 7.4. The angle of elevation to the top of a tree is 52 degrees from the tip of its shadow when the shadow on the ground is 47 feet long. What is the height of the tree? So here we're considering a tree, so here's my tree, so on. Okay, and we have its shadow on the ground. Okay, it says the shadow on the ground is 47 feet long. And we get this triangle. It says the angle of elevation to the top of the tree from the tip of the shadow, so this angle right in here is our angle of elevation, is 52 degrees. And we're assuming the tree forms a 90-degree angle with the ground. And we want to find the height of the tree. I'll call this h. So I'm going to draw another right triangle that's similar to this one, but one of which I know all three side lengths. So this is 52 degrees. So the hypotenuse is 1. The opposite side is sine of 52 degrees. The adjacent side is the cosine of 52 degrees. And now I'm going to set up a proportion. 47 over, well, h over 47, coming from the diagram that we made, would be proportional to sine of 52 over the cosine of 52. Now we can work with both the sine and cosine of 52, our calculator works with that, or we can change that to sine over cosine is tangent, and I'm going to use that. So h over 42 is equal to the tangent of 52, and you could put tangent over 1. If you cross multiply in this proportion, we end up with 42, well, let's do h times 1 first. H times 1, which is h, is equal to 42 times the tangent of 52 degrees. And then we get our calculator to get an approximate height here. 42 times the tangent of 52 degrees comes out to be approximately 53.8 feet, and I'm rounding to the nearest tenth. Part B. We have the angle of elevation from a car to the top of the Eiffel Tower is 50 degrees, so here's the angle of elevation. The car is 100 meters away, so this base length is 100. How tall is the Eiffel Tower? So the height here. I'm going to draw another right triangle that's similar to this one. They both have a 90-degree angle and a 50-degree angle of elevation. Hypotenuse is 1. Opposite side is sine of 50 degrees. Adjacent side is cosine of 50 degrees. And set up a proportion. Here we have h over 100 is equal to sine of 50 over cosine of 50, which is the tangent of 50 degrees like we saw in part A here. So height over 100 is the tangent of 50 degrees over 1. If you cross multiply, you end up with h times 1 equals 100 times the tangent of 50. So the height is, multiply this together, 100 times the tangent of 50 degrees, and we get approximately 11.9 meters. And actually checking that doesn't make sense, and I see that I entered it wrong into my calculator. Let me try that again. 100 times the tangent of 50 degrees is 119.2 meters, approximately. Part C here, we have a 6-foot board that rests under a doorknob at and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? So we have our door. We have this piece of wood that's resting right underneath the doorknob. The board is 6 feet, and the board is 5 feet away. So 6-foot board rests under the doorknob, and the base of the board is 5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? And so we're looking for h. So in this case, we don't need to work with similar triangles because we know 2 of the 3 side lengths, and we're looking for the third side length. So this is the case we're going to use Pythagorean Theorem. H squared plus 5 squared equals 6 squared. And so h squared plus 25 equals 36. Subtract 25 from both sides, and we get h squared is 36 minus 25, which is 11. And then take the square root of both sides, and h is going to be the square root of 11. For section 7.5, we're going to use the law of sines, which states that if I have a triangle, and does not have to be a right triangle, so say triangle ABC, we use capital letters for the vertices where the angles are, and then lowercase letters for the side lengths opposite to those angles. Then the sine of angle A over side length A is equal to the sine of angle B over side length B, and that's also equal to the sine of angle C over side length C. So in our problem here, we're trying to find all the missing sides and angles. So we're missing angle A, we're missing angle B, so I need angle A, or the measure of angle A. I want the measure of angle B, and we're missing side A. So when I set up my proportion, here's what we know. We know, okay, sine A we don't have. So I'm going to write sine A over A, we don't know either of those, is equal to sine of B, we don't know what that is, over this 11, because that's the side length opposite B, and that's equal to the sine of C, which is 101 degrees, over 20. And I want to start by picking just 2 of these fractions and setting them equal to each other to solve for a variable. I'm going to pick the last 2 because there's only one variable in that proportion, and it'll be easy to solve for that one. So I'm going to cross multiply and get 20 times the sine of B is equal to 11 times the sine of 101. And then I'm going to divide by 20 and get the sine of B is equal to 11 times the sine of 101 divided by 20. I'm going to enter that part into my calculator. So 11 times the sine of 101 and then divide by 20, and I get 0.5398 0.94, and so on. I'm going to use as many decimal places as I can in this part because I'm not done solving. When I get to B, I'm going to round to the nearest tenth. But in the process, I want to maintain as many decimals as I can to get more accuracy. So to get B by itself, I need to take the inverse sign of this. And we're going to get an approximate value here. This is already an approximate value we're working with. So when I take the inverse sign, I get approximately 32.8, rounding to the nearest tenth. And we're talking degrees. So the measure of angle B is approximately 32.8 degrees. I know the measure of angle C. We found the measure of angle B. We can now do some work to find, so this is all for measure for the first part here, right? All three angles add up to 180. So capital A, that'll be the measure of our angle A, plus B, which is 32.8 roughly, plus 101 is equal to 180. So A plus 133.8 is equal to 180. And subtract 133.8 from 180, and you get measure of angle A is going to be roughly 46.2. And lastly, we're after side length A. And now I'm going to go back to that original fraction that we set up. And this time I'm going to use, doesn't matter, I'll maybe use the first two. And plug in what I know. So sine of A, we have A now, sine of 46.2 degrees over little a is equal to sine of B, so 32.8 degrees over 11. Cross multiply, and we get A times the sine of 32.8 is equal to 11 times the sine of 46.2. So A is going to be 11 times the sine of 46.2 all over the sine of 32.8. Very carefully plug this into your calculator. Use parentheses correctly. If you have trouble, you may want to find the sine of 46.2 first, the decimal value, and the sine of 32.8 decimal value, and then plug it in. But let me do this and tell you what you should come out with. So you should get A is about 14.7. And so we found what we were looking for. Now for part B. Again, we're going to solve for all the missing sides and missing angles. Let's see what we're missing. We don't know angle C, so we want the measure of angle C. We don't know side B, and we don't know side A. So measure of angle C we'll do first. That's the easier part. We know all three angles add up to 180. So C plus 73 plus 14 is 87. Subtract 87 and you get C is going to equal 93 degrees. And then we're going to use the law of sines to help us find A and B. From the law of sines, we can say that the sine of A, which is sine of 14 degrees over A, is equal to the sine of B, so the sine of 73 degrees over B. And then that's also equal to the sine of C, which we found that C is 93 degrees over C. And this time we know C is 13. And so we picked two that we want to work with. We don't need all three fractions. So I'm going to use the first and last. Sine of 14 over A is equal to sine of 93 degrees over 13, and that will help me solve for A. And then I'm going to use the last two to solve for B. So let's cross multiply here, and we get A times the sine of 93 degrees is equal to 13 times the sine of 14 degrees. Divide by the sine of 93 degrees, and you end up with A is 13 times the sine of 14 degrees divided by the sine of 93 degrees. Carefully enter that into your calculator and check to make sure you're getting the same thing I get. You should end up with approximately 3.1. For A. And then to solve for B, we're going to use the last two fractions. The sine of 73 over B is equal to the sine of 93 over 13. Cross multiply, B times the sine of 93 is equal to 13 times the sine of 73. Divide by the sine of 93 and you get B is 13 times the sine of 73 divided by the sine of 93. Use your calculator. And you should get approximately 12.4. And then we got our missing sides and missing angles. Last part, we're going to find the area of triangle ABC where A is 37 degrees, B is 25, and C is 16. So let me draw this triangle here. So here's where A is. I'll make this B, make this C. So B is 25, little b, and little c is 16. Well, the area of a triangle in general is 1/2 base times height. And so if we let 16 be our base, we know our area is going to be 1/2 times 16 times the height. Now the height is the altitude of this triangle, so you drop a 90-degree segment from C to the base, and whatever, I'll call that H, whatever H is our height. So we need to figure out what H is, and then we can plug it in and get our answer. Now we have a right triangle here. I'm gonna separate it. We have this 37 degrees here, we have 25, and we have H and a 90-degree angle, so I can set up one that's similar. Where the hypotenuse is 1, we get the sine of 37 as the opposite side length, and the cosine of 37 as the adjacent side length. And so we can set up a fraction. We could say that h over 25 is the same as sine of 37 over 1. And if I cross multiply, I'm going to get h is equal to 25 times the sine of 37. So I'm going to take that and plug it into our equation here. And so now we get the area is 1/2 times 16 times 25 times the sine of 37 degrees. Use your calculator. And we get the area is approximately 120.4 square units. So this is section 7.6, the law of cosines, and we need to solve the triangle for all the missing parts. We are given side, angle, side in this case. And so we need to find side A. We need to find angle C and angle B. So to find side A, I'm going to use the law of cosines. Law of cosines says that a squared is equal to b squared plus c squared minus 2bc times the cosine of angle A. And I know little b and little c and angle A, so I can plug those things in. So a squared is 23 squared, b is 23, plus 22 squared minus 2 times 23 times 22 times the cosine of angle A, which is 104. You could put this in your calculator. 23 squared plus 22 squared minus 2 times 23 times 22 times the cosine of 104. And you get a squared is approximately 1,257 point. I'm gonna maintain a lot of decimal places here until I get to my final answer. And then take the square root of both sides. So a is going to be approximately the square root of that. And now I'm going to round to the nearest tenth, and I get 35.5, roughly. Now once you find this first missing piece, you could go back to the law of sines and solve for one of the angles, or you can still use the law of cosines. So say I want angle C next. So then I start with c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. And so in this case, c squared, or c is 22. A we just found is 35.5. B is 23. And we don't know the cosine of c. So 22 squared is 484. 35.5 squared plus 23 squared is roughly 1789.25 minus 2 times 35.5 times 23 is 1633 times the cosine of c. Now you might be tempted to subtract 1789.25 or subtract the 1633 from the 1789.25, but you would be wrong to do that because order of operations says you need to multiply that 1633 times the cosine of c before you can do any subtraction there. Instead, let's solve for cosine of c. So first, subtract 1789.25 from 484. And you end up with negative 1305.25 is equal to negative 1633 times the cosine of c. Then divide both sides by 1633. And you end up with 0.799295777 or 775 is equal to the cosine of c. I want to get c by itself, so you got to use the inverse cosine function. So c is equal to the inverse cosine of this number. Using the calculator, I get C is roughly 36.9 degrees. Now that we have angle C, we know angle A. Angle B is not going to be too tough to get, because when you add the three angles up, you get 180. So 104 plus angle B plus C, which is 36.9, is equal to 180. So 104 plus 36.9 is going to be 140.9, plus B is 180. Subtract 140.9 and you end up with 39.1 degrees for angle B. And now we have our answers. And last one, part B here. Here we have three side lengths, so we need to find all three angle measurements. So we need the measure of angle A, measure of angle B, and the measure of angle C. Go after the smallest angle first, which would be angle C. So using the law of sine, C squared is equal to A squared plus B squared minus 2AB times the cosine of C. If you want, what you could do is get the cosine of C by itself before you even plug anything in. I'm going to do that in this problem. It's all preference, it's up to you. So I'm going to subtract A squared, subtract B squared, and I get C squared minus A squared minus B squared is equal to negative 2AB times the cosine of C. Again, still trying to get the cosine of C by itself, so I need to divide by negative 2AB. I may hold off here. Let's hold off here, because it may get a little too much when you're plugging everything in. But you can manipulate the equation before you plug things in, or you can plug things in first and then manipulate the equation. Your choice. So C squared, let's plug things in here. So C is 11, so 11 squared minus A is 15, 15 squared, minus B is 13, so 13 squared, is equal to negative 2 times A times B times the cosine of C. So I'm going to use my calculator here to get 11 squared minus 15 squared minus 13 squared, which gives negative 273, is equal to negative 2 times 15 times 13, which is negative 390 times the cosine of C. Divide by negative 390. And you get 0.7 is equal to the cosine of C. To get C by itself, you take the inverse cosine of 0.7. And we get C is roughly 45.6 degrees. We need to find another angle. I'm going to use the law of sines here. I'm going to go after angle A. So, or maybe B. We know that the sine of B over side B is equal to the sine of C over little c. We can also say it's equal to the sine of A over little a too. But this gives me a proportion where I can cross multiply and get 11 times the sine of B is equal to 13 times the sine of 45.6. I'm going to divide by 11 and I get the sine of B is equal to 13 times the sine of 45.6 over 11. I'm going to use my calculator and get the sine of B, plug in 13 times the sine of 45.6 divided by 11, and we get 0.844376803. So B is the inverse sine of this number, which is approximately 57.6 degrees. Now we have two angles, we're missing one more, and we know that all three add up to 180. So A plus, if you add 57.6 with 45.6, you get 62.2. And subtract that from 180, and you end up with A is 117.8 degrees. Something went wrong here. It's not 62.2. Always good to go back and check your answers here. So 57.6 plus 45.6 is 103.2. Subtract that from 180, and you end up with 76.8 degrees. And you have found all three angles.